Hi everybody, this is the Math 30-1 Trig 2 review. It says, this is question 20. Determine a sine function and a cosine function for a graph that has a minimum of negative pi, negative 3, and the nearest maximum to the right is pi 5. So basically what we're being asked to do here is to come up with these equations given the absolute minimum amount of information that we could. So negative pi, negative 3, 1, 2, 3, puts us right here. And pi 5, okay, pi 5 puts us up here. And so the function looks something like that, okay? Now I don't know, that's just me kind of roughing it out here. What's important to note here is that this is our minimum, this is our maximum. Now regardless of whether we're dealing with sine or cosine, there are three variables that are going to be the same here. And they're going to be related to your max and your min. So our max is equal to 5, our min is equal to negative 3. Okay, well A is max plus min over 2. So that's going to be 5, I'm so sorry. A is max minus min. A is max minus min. I've been doing it like that the whole time through, and that's the correct way to do it. So max minus min here. So 5 minus negative 3 divided by 2. 5 minus negative 3 is 8 divided by 2 is 4. There's my amplitude, 4. The D value, the vertical translation, will be max plus min. This is the one that acts more like an average. Max plus min over 2. So 5 plus negative 3 over 2. Okay, 5 plus negative 3 is going to be 2. Divided by 2 is 1. There we go. So right there, we have got the A and the D values. Now let's look back at our graph here. Okay, to go from negative pi to pi, that's a displacement there, a difference of 2 pi radians. But notice that this is only half of a period. Okay, the other half of the period would bring us back down again. That would be another 2 pi radians here. So I can tell by looking at this that my period has to be 4 pi. Okay, because again, I go from negative pi to pi horizontally, and that is only half a period. Going from the bottom to the top is just half a period. So it's got to be 4 pi. Now, my B value is going to be 2 pi divided by the period, so 2 pi divided by 4 pi, and you can simplify that to get a half. So there we go. Right away here, we have got A, D, and B to put into this equation here. Now, we just got to pick one of them. We're going to pick, for example, let's pick sine. To get sine here, I know that sine starts at the middle. I know that a sine graph should look like this. If I put a little box around it, sine graph should start at the center, should go up, down, all the way, and then up in the middle here. So I'm going to draw my line through, a horizontal line through my D, my vertical translation. That's going to be right here at 1. And notice that where I intersect the graph, okay, the graph is going up. This is the beginning points of my sine graph. And what's beautiful about this question is that it is right on the y-axis where it should be. Okay, it's just been moved 1 unit up here, but it hasn't been moved horizontally. So my sine graph can look like this. Y is equal to positive, my amplitude is 4, sine of, my B value was a half, but there's been no horizontal phase shift. And then it's been moved up 1, and there we go. And so there's my, oops, that's right, wanted that to look better, made it worse. There we go, plus 1. Now I'm supposed to come up with a cosine graph. Well, cosine, a positive cosine, starts at its peak, at its apex. And that should be on the y-axis, but it's not. It's been moved over. It's been moved pi units to the right. So that becomes my horizontal phase shift. So now the A, the B, and the D values stay the same. So y will equal 4 cosine of 1/2, except now this thing has been moved pi units to the right. So minus pi plus 1. And those are our two trig functions that we were looking for.